All right. And there we go. This should be working now. Yeah, that looks good. Right. So day 4 of Advent of Code. Here we go. So again, of course, nothing in my folders here. Haven't looked at this yet. So it appears we're going into this bay to go further into the jungle. So let's see. I'm just trying to keep an eye on all the chats and stuff. Right. Day 4, damp cleanup. Sounds nice. Space needs to be cleared before the last supplies can be unloaded from the ships. And so several elves have been assigned the job of cleaning up sections of the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their section assignments with each other, they've noticed that many of the assignments overlap. Well, that's not great. To try to quickly find overlaps and reduce duplicated efforts, the elves pair up and make a big list of the section assignments for each pair. So elf ID number or something. And that is our puzzle input. For example, consider the following list of section assignment pairs: 2, 4, 6, 8, 2, 3, 4, 5, 5, 7, 7, 9, and so on. For the first few pairs, this list means within the first pair of elves, what on earth? Within the first pair of elves, the first elf was assigned sections 2 to 4, so sections 2, 3, and 4, while the second elf was assigned sections 6 to 8, so 6, 7, and 8. The elves in the second pair were each assigned 2 sections. Okay, the elves in the third pair were each assigned in 3 sections. One got section 5, 6, 7, and the other also got 7 plus 8 and 9. So, what? The elves pair up. Right, I missed that part. Okay. This example list uses single-digit section IDs to make it easier to draw. Our actual list might contain larger numbers. Visually, these pairs of section assignments looks like this. So no overlap here, no overlap there. Here we have an overlap. Here we have a big overlap. There's an overlap, and here we have an overlap. Some of the pairs have noticed that one of their assignments fully contain the other. For example, 2 to 8 fully contains 3 to 7. And 6, 6 is fully contained by 4, 6. In pairs where one assignment fully contains the other, one elf in the pair would be exclusively cleaning sections their partner will already be cleaning. So these seems like the most in need of reconsideration. In this example, there are 2 such pairs. In how many assignment pairs does one range fully contain the other? Right. To begin, get your puzzle input. Right. So here, as it said, we now have larger ranges. It's not just single IDs. None of them seem to be more than 2 digits, though. Not that we're going to exploit trivialities like that. I tend to always try and write my solutions in the most general kind of way. So someone pointed out that my video has a nice thumbnail. And yeah, I guess that is my That is my old, I guess it was Google Plus image or something like that. It's yeah. Right. So there's our input. Of course, this we could do just normal like string splitting and stuff, splitting them on this and splitting on these. We could also use a parser generator of some kind. I saw there was a new one that had just been released. I might have to look at that one for some of the later challenges. Typically, I would use npeg, which is a fantastic parser. But yeah, for this, I think we're just gonna go with splitting. And I wonder if we can do this with sets. We probably could. One thing to note, though, the ranges always seem to be increasing. So from low to high, we never have one saying which goes like 8 to 2, for example. So we'll definitely use. Oops. One. So I think we're just going to use string utils, and we are going to. The way we can do this is basically have we can use sets from that we used in the last solution, and we can say this set include this set, and check if the size of the set has increased. So that is probably the easiest way of doing this. All of the IDs, I said we were going to do it generally, but all of the IDs seem to fit in a 256 or a uint8. So there's no problem in using the built-in sets. The built-in sets are bit sets. So if you have very high numbers, then you can't use them because the resulting bit set would just be massive. So if you have sparse data with large IDs, you either need to come up with a scheme to make smaller IDs, or you need to use the hashset module. So yeah, let's grab. I don't think we need the set utils actually. So we can go again for line in input txt.lines. So loop over every line. Then we can have the pair. So one elf and one elf is line dot split on the comma. So that would split this into this and into this. And then, so if we echo out the pair, so yeah, here we can see that we have all our numbers split up nicely there. So now we can take actually, so since these are sequences, so we can run this in a loop, but let's not do that. First range is the first of these, split that on this character, and we can do this with character literals actually. Don't have to do a full string literal. First range and the second range is our two pairs. Actually, what we could do, so I'm just going to show this. A lot of people, when they do these and try to make them as short as possible, yeah, so here we have all of the ranges by themselves. a lot of people, what they do if they want to make stuff shorter is to use functional styles, because then you can sort of chain stuff onto lines. So what we can do here is do this and then say it.split, for example, on this, like that. And if I now echo out the pair, we now have a sequence of sequences, which is pretty nice. We could also do, so after we split that, we get a new sequence. We can run map it again and then say it.parseInt. Now it is fully parsed into two integers for us, which makes our job a little bit easier. So that means we can do something like the first range is now the pair. So the first elf in the pair. Actually, let's do a set of uint 8. And then we do for I in pair 0, 0, dot pair 0, 1. So that will loop from the 0th element in the sequence from the 0th to the 1th inclusive, which is what we want. And then do first range include this value. So if we now have a look, this of course have to be a variable since we're modifying it. And this has to be a uint 8 since our set is a uint 8. So this will output a set with 9 to 76 in it at the bottom here. So 9, 10, 11, 12, blah, blah, all the way to 76, which is exactly what we wanted. Wonder if there's a better way of doing this. Is there a way to include a range in the built-in set type? I wonder. The built-in set type is unfortunately a bit under. Right, so we can do this actually. Let's see if that works for this. Just say that this is the set from pair 0, 0, dot pair 0, 1 in the set construction syntax. Oops. And let's just comment out those lines. Right, that seemed to work. Easy enough. So now we have the first range. Now we can make the second range. Second range is just going to be the exact same thing, but with, of course, pair 1, like so. And now, so now we have the first range and the second range. So now we have our two ranges. So for the last one, it is this set and this set. And actually, let's do like we did last year and grab this. Just grab a copy of that, and then when I move my hand back and forth to the mouse, I tend to shift my hands like over by one. Right, so let's make a file. Just drop this in there. And then in here, do test input. So now we can test with the input that was given in the text. So yeah, here we can see 2, 3, 4, 5, 6, and 4, 5, 6, 7, 8. That is the 2, 3, 4, 5, 6, 4, 5, 6, 7, 8. So this is a bit more easy to look at than the big example up there. So basically what we want to do now is we want to check if the first range dot cardinality is equal to first range, and now we want the union. So no, we want the what's it called? The intersect. No, not the intersection. The yeah, I guess it would be the union. Yeah, the union of these two sets. So all elements in both sets. And we want to check if the size of either of the original ones is equal to the size of the union. That means no new values were added to that one, which means it contained all of them. So we can do this, which is the union range, first range plus second range. And then we can check if the first range cardinality is equal to the cardinality of the union range, or the second range cardinality is equal to the union range cardinality. That means one is completely consumed by the other, or completely encompassed by the other. So if we just echo those out, we can see that 2, 3, 4, 5, 6, 7, 8, and 3, 4, 5, 6, 7. So this one, of course, fits perfectly in there, and this 6 fits perfectly in there. That is good. Of course, another way of doing this would be to say max of first range dot cardinality and second range dot cardinality is equal to the union range cardinality. It just makes the whole thing a bit shorter. So basically, the biggest one of these, so if the largest set is equal to the size of the full union set, so this one is going to be the largest, this one is going to be the largest. If either contains the other, then we're good. And I guess max, if they're the same size, I guess it returns the first range. So what would actually happen in that case? Yeah, that should be fine. As long as they're, yeah, if they're identical, this will also work fine. So, and the, sorry, this isn't scrolled in or zoomed in. So, in how many assignment pairs does one range fully contain the other? So how many? That means we just need a counter of the completely contained, and we want to increase the completely contained, and at the end we want to see the completely contained. And there we go. We have two of them in our example, which is of course what we expect. And if we run it on our full input, we get 431 for my input. And that's the right answer. You're 1 gold star closer to collecting enough starfruit. Nice. So before we start reading part 2, I forgot this last time. I forgot to copy my part 1 into a part 2 file. So for the Git repository, I had to watch my own stream back and recreate the original part 1 file, which was a bit annoying. Part 2. It seems like there is still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. So, not completely overlap, but they overlap at all. In the above example, the first two pairs, 2, 4, 6, 8, and 2, 3, 4, 5 don't overlap, while the remaining 4 pairs, 5, 7, and 7, 8, because they're 7, 9, because they share the 7, 2, 8, 3, 7, 6, 6, and 4, 6, and 2, 6, and 4, 6 do overlap. So in this example, the number of overlapping assignment pairs is 4. And how many assignment pairs do the ranges overlap? So our solution for day 1, once again, proves to be very useful for day 2. Basically, what we want to check is if we have an overlap, then the cardinality of set A plus set B, so their union, the cardinality of that would be smaller than the cardinality of both added together. Or we could check if the intersection of the two sets, so those that only appear in one of them, we can check if that intersection has a cardinality of more than 0. Of course, for this one, we could have also checked if the difference between the two sets matched something. But yeah, for part 2, what we're going to do is we're going to say if first range cardinality plus the second range cardinality is larger than the union range cardinality, then we know that there is an overlap, because these two, so let's say each of them have 5, that means 10, but they have 3 overlap, so they have 7 unique ones. That would mean that 10 is larger than 7, and we have an overlap. So what we're going to do, we're going to rename this to some overlap, and we're going to run this. That gives us 823. So the other solution, of course, is to go check if the union, or not if the union, if the intersection range, so the range that is the intersection of A and B, so the range that is the intersection, we can now check if the intersection range is greater than 0. So if there is any intersection between the two, and of course the cardinality of that, we can check that that is also 823, which is the same that we got for right. It's the same that we got for the other one. So that is likely our answer. Oops. What did I say? 823. That's the right answer. You are 1 gold star closer to collecting enough starfruit. Nice. That was day 4. Pretty easy. Not a whole lot of issues there. Pretty similar actually to yesterday's solution. But yeah, nice and easy. I was thinking, so these streams, of course, they take a little bit of time to do, but a lot of that time is sort of wind up and wind down, like getting the stream running, letting people know, like saying hello, saying goodbye, sort of getting into it. So I was wondering if we should do fewer streams, but like say every weekend I do the whole week. Of course, that would mean the next stream wouldn't be until here somewhere. That would mean only like 2 or 3 streams for all of these, which might not be great. But yeah, I'm considering something like that, just to make these streams a bit more interesting to watch and a bit sort of easier to plan around. Then I could have I could say when the stream would start, stuff like that. A bit better than I can at the moment. But yeah, that was it for day 4. So now it seems that the bay has almost ended here. It seems to be some mountains or something on the beach, which is a bit strange. Maybe they're not mountains. Maybe there's something more on top of there. But yeah, so I will probably do another stream tomorrow. Hopefully. But yeah, that was it for day 1. Of course, as always, you can find my solutions in the GitHub repository, AoC 2022. So you can find my solution here. I will upload my solution for today there right after the stream. And that's it for me. So